you're going to need to keep your heads about you with this one. We have already learned how to solve simultaneous equations with two unknowns, so two equations and two unknowns. However, if we have 3 points and we need to find the equation of the parabola that goes through all those 3 points, we're going to have to solve simultaneous equations with 3 unknowns, so we're going to have to come up with 3 equations. Okay, so in the form, we're going to have to use our standard form. We don't have turning point, we don't have x-intercepts, so we're going to need to use that. Okay, so we're going to use each of those points. So using 1 and -4, I'm going to have, substituting in there, -4 is equal to a plus b plus c. And that's equation 1. So I'm substituting in my x and my y values. Using -2 and 23, I get that 23 is equal to, well, -2 squared is 4, so it's going to be 4a minus 2b plus c. And using 3 and -2, I get that -2 is equal to 9a plus 3b plus c. Okay, now I have a bit of a foolproof method to do this, because you'll all notice that in each one of these equations I have only got one c. So if I can eliminate c, I then have only 2 unknowns with my a's and b's, and I'll only need to solve for 2 equations then to solve for them. What do I mean? Well, let's do this. If I say equation 1 minus equation 2, okay, I've got -4 minus 23 is equal to a minus 4a plus b plus 2b, and the c minus c falls away. So I have minus 27 is -3a plus 3b, and I'm going to call that equation 4. And if I then say equation 1 minus equation 3, so notice 1 minus 2, now I'm going to do 1 minus 3. Okay, so I have -4, take -2 is equal to a minus 9a plus b minus 3b plus c minus c, and that disappears. And so I have -4 plus 2 is -2, a minus 9a is minus 8a minus 2b, and I'm going to call that equation 5. Now notice, equation 4 and equation 5 have only got 2 unknowns. You know exactly how to solve simultaneous equations with 2 unknowns. I'm going to rearrange one of them. So from equation 5, I'm going to say, all right, ugly. From equation 5, I'm going to make it so that it's a equals or b equals, just so that I can work with things. So let's make it b, let's make it a equals, okay? So we can have 8a is 2 minus 2b, and a will be 2 minus 2b on 8. Look, you could have divided everything by 2 as well. Okay, and I'm going to substitute that. We'll call that equation 6 if we like. And I'm going to substitute 6 into my equation 4. Just make sure that you're substituting into the correct ones. so that we have negative 27 is equal to negative 3 times 2 minus 2b over 8 plus 3b. All right, so it looks like a little bit of complicated algebra, but it's not too terrible, I don't think. We can divide every single term by 3, so that, and actually if we divided it by negative 3, we'd get rid of that negative, so 9 is 2 minus 2b on 8 minus b, and then I can multiply every single term by 8, so 9 8s are 72, is 2 minus 2b minus 8b, and I can take the 2 over, so 70 is equal to negative 10b, so b will be equal to negative 7. What's nice about that is then I can substitute that in to get my a value. So I'm going to substitute b equals negative 7. Now I'm going to substitute back into 4 or 5. Okay. Into 4 to determine my a value. And so I've got negative 27 is negative 3a plus 3 times negative 7, and 3 times negative 7 is negative 21. Taking it to the other side gives me a value of negative 6, and negative 6 divided by negative 3 means that a equals 2. Now once I've got an a and a b value, all I'm still looking for is c, so I'm going to substitute a equals 2 and b equals negative 7 into equation 1 to determine c. And that means I'm going to have negative 4 is equal to 2 minus 7 plus c, and that means I have negative 6 plus 7 is negative 1. What is a positive 1? Negative 6 plus 7, positive 1. Okay, so therefore my equation, going through those 3 points, is y equals 2x squared minus 7x plus 1.